Hi everyone, I promised a tutorial over the Boyle Prep DNA extraction, how to make the Boyle buffer. So that's what we're doing today.
This project is extremely dangerous.
No, it is not. It is not. I'm not really sure what's going on, but I do have special guests in my office today, so I'm sure that will be interrupted, but it's okay.
Danger, danger, Will Robinson.
Okay, it's going to be fine. All right, so what would we do? We know this is a solution, and, right, and we're going to make our Boyle buffer. We know it's a solution, and we know we need all of these things all in one volume. But that means we need to make each one separately in the total volume of 400, and then we put them all together into that total volume. When you have multiple solutes in a solution, each one has its own percentage or molarity, independent of the others, but they're all in the same thing. So, what do I mean?
Does not compute.
Yes, you're gonna be fine. It's gonna be fine, okay? So, what do we need to do? We need to make our Triton X, and so that's just 100% solution, right? So we need to make that guy, and then we need an 8% sucrose, that's a solid crystal, and then 50 millimolar EDTA, our stock is 0.5 molar, 10 millimolar tris, pH 8, and our stock is 1 molar. So let's just break it down and start with each one and do one at a time, and that will make it a little bit simpler.
Affirmative.
Yes, thank you. Okay, so what are we going to do? What do we have? So if we're going to start with our little Triton guy, what do we have? We have 100%. How much do we have? We don't know. That's our whole point, right? We're trying to find how much of that 100% do we need to make 0.5% in 400. That's our total volume for the whole stupid thing. Okay? So remember, each one's molarity or percentage is separate from the other solutes. We're not looking for total concentration of all the solutes together. Each individual solute has its own percent or molarity. So then we just do that math, right? If we're going to work it out, we'd go V1 equals all of that over 100%, and then we always carry our units, right? We carry our units, those guys cross out, and then we do the math, and that equals what? It equals 2 what? 2 ml. That's the only guy that's left. Ta-da! So we know we need 2 mils of 0.5% Triton X100.
Does not compute.
Yes, it does. Everybody's with me on that one. So I don't want to hear it. Okay. Same thing, same thing. What is 8% sucrose? Right? We learned our little rule that percents are grams per 100 mils, right? And so what do we have? We have 8 grams, 100 mil, right, equals how much? Well, if we're going to do the cheater method, we want 400 mils total, so what do? Times it by 4. So then what do we have to do? If we times the bottom by 4 to get 400, that's our total. What do we have to do to the top? Multiply by 4. Whatever we do to the top of an equation, we do to the bottom of the equation. Right? That's how math works, right? You can multiply by 100 on top, 100 on the bottom. It's still the same ratio. So if we multiply by 4 on the bottom to get 400 total, how many grams have to be in that 400 to keep it at that 8%? 32.
Due to worn conditions of memory bank, compliance impossible.
Come on. You're with me. Be silly. Silly robot. Okay. What's next? Oh! we are doing, what are we doing? We are doing, back to 50 millimolar EDTA. What do we have? We have 0.5 molar, right? 0.5 molar, which is the same as, I'm looking at my notes and I can't even see. It is, oh, okay. So 0.5 molar is the same as saying 0.5 moles per liter. And we need to know how much of that guy. And then what do we want at the end? We want 50 millimolar, right? So what is 50 millimolar in moles? 50 millimolar? What is it? What is it? What do we know? What do we have? Oh my gosh. What is the story with this conversion?
Insufficient data.
No! Come on. All right. We have how many? Okay, so how many millimoles or millimoles are in a mole? So 1,000, right? In one. So what do we have to do? We either convert one side to millimoles or the other side to moles. Molar. Sorry, millimolar or molar. So this one can really just stay as molar if we want to, because then we can just kind of cheat a little bit. And so if we want 50 millimolar, and there's 1,000 millimolar per moles, and we want to convert this into moles, we go 1, 2, 3 zeros. 1, 2, 3, right? Right. And so we would say 0.05 moles. 0.05 moles, sorry, molar. What is my problem, people? 0.05 molar is the same as 50 millimolar. So if I just confuse the living baloney out of you, I apologize. Oink. And then what is it in? 400 ml, right? And there we go. All we have to do is the math. And so we're going to do that little, right? And we cross that out. We do the math. And what are we left with? For what? For ml. Ow! 40. Sorry. I lied. Ugh, that's terrible. I'm sorry I lied.
You're wasting our time, Earth creature.
I'm sorry. I'm not making this tutorial again. Just going with it. Sorry. 40 mils. Right? Because that's the guy that's left there. And then we got one more. One more. Same idea. We're going to squeeze it. Uh-oh. And we're going with, this time, we want 10 millimolar Tris pH 8. That guy. Right? And so, same idea. This case, we're starting with 1 molar. We have 1 molar solution. Times how much of that are we going to use? And we're going to do the conversion, same as we did before. We want to change 10 millimolar. 10 millimolar. Into molar. If we have 1,000 millimoles per molar, then we go 1, 2, 3. 1, 2, 3. Boink. 0.1 molar. Times 400 ml. Do the math. This time V1 equals 4 ml. Okay, so those are all the separate equations.
Affirmative.
So that they can all be at their respective molarities, percentages. Molarities and percentages. So, when that happens, we're not done yet. You can't just leave. Sorry, I'm just going to move this guy over here. And what do we have? So we have 32 grams of sugar. we have 2 mils Triton at its volume. We have 40 mil EDTA, and we have 4 mil Tris. Okay, all in a volume of 400 mLs. So what do we do first? Well, first let's add up to see how much liquid we have. So we have 40 plus 4, 44, 46 mils. So we have 46 mils of liquids that we're going to add. And so how much do we have? How much do we have of, at least do we have of water about in there, right? So we'd take 400 minus 46, and that would be, I don't know, what would that be? 54. Whoa! 354. Right, and then that gives us 46 mils left over. Do we want to take our graduated cylinder or our beaker and fill it to exactly 354? No, we don't want to, because the sugar's going to take up some space, some volume.
Danger, danger, Will Robinson.
That's right. So we are going to start with, we'll say 300 is a nice safe number. So from that, we're going to start 300 mLs of good old H2O into our graduated cylinder, like that. Then, what are we going to do? We're going to put our sugar in there. We're going to add a little stir bar. We're going to put it on the metal stir plate. We're going to turn it on. And it's going to start stirring. Woohoo! Until we dissolve that sugar. Then we're going to add the 40 mils of the EDTA, the 2 mils, the 4 mils. We're going to spin, spin, spin. And then we're going to add up to... I can't find the right color. Up to the 400 mil mark on our graduated cylinder. And then everything is exactly the way it should be. And everything's wonderful. And that's how you do multiple things in one solution. Each solute separately first. Then you get your Dielmeyer. Then you figure out about how much water. Do a little bit less. Dissolve any solid first. And then put the rest. You got it, yes?
You're wasting our time, Earth creature.
No! Come on, you're seriously? Are you getting it?
Affirmative.
All right, then that's it. We're done. Thanks so much. Next time, maybe I'll get more support from my audience. Thank you!